I'm glad you're here to watch me struggling with this build. Have fun! Recently I got 2 packages from CNC. I often buy CNC stuff from them considering they have quite good quality to price ratios. One of those packages are linear rails for the X-axis. I cut them to size with my best friend. I made some custom spacers to make the alignment a little bit easier. And there we go with the banana shape of the plate due to some human error from the last time. Filler gauge tape should help here. I've got to fill up to about 0.6 mm gaps. But first things first. I filled up all gaps with that tape. And I went straight to the next guide. Again, same process. Almost perfect. Let's head on to the ball screw. All of these parts are the same as on the Z-axis with one exception. It will be the motor to screw coupling. On the Z-axis there was a timing pulley and here will be a plumb type flexible coupler. Everything is set to the dimension and measured twice. I decided to equip the linear blocks with fittings to make a greasing system later on. This type of blocks have M6 threads on both sides. The blocks are mounted on the rails, ready for the grease. I also added a fitting to the ballscrew nut. In meantime, I decided to equip the Z-axis screw with a spiral cover. I added its simplified design to my machine 3D model in ZW3D. Thanks to that, I was able to design the mounts for it. You can see here the designing process. There is a lot to consider, a lot of possibilities to have collisions. And that's where the 3D designs get really handy, not mentioning all the rest of the machine. At least I forgot about the welds I made, so I had to modify the design anyway. The 3D printer allows me to turn stupid, irrational and absurd designs into parts made really simple and without no effort at all. There is the spiral cover. And after some assembling, it looks like a lot of fun. Now the X-axis servo. Some thoughts made me modify the design of the motor mount a little bit. And I went to the pencil and paper. I got some steel and went to the real work. All the markings will help me out with some rough cuts with the angle grinder. Lines are done and ready to be removed. Now let's remove also the burrs after cutting. The mill will help me handle all the precision features. Quick G-code for drilling and lets the chips fly. Setting the coordinates lets the mill do its work. Quick chamfers now. And the part is ready for threading. Keeping in mind what happens on the drawing, the assembling seems to be easy. MIG welding helps me to glue that stuff together. The part seems to look similar to the one on the paper. And surprisingly, it even fits to the motor flange. Now, I mentioned in the beginning of the video that I got some stuff from HLTNC. There is a second package. They have a lot of CNC related stuff, and all of that will be used for my CNC lathe in future videos. They have proximity sensors, mechanical limit switches, coolant mist systems, drag chains for cables, power supplies, rail covers, and couplings. This is what is the most interesting thing for me today. It will pass on the torque from the servo to the axis ball screw. And it fits perfectly. And the drive system seems to be ready. If this project seems interesting to you, I encourage you to watch the last parts of the series, leave me a comment and subscribe to the channel. If you made this far, a huge thanks for watching and have a nice day.